I think it's a good time to get started. Richard, I'll let you take it away.
Yes.
Thanks again for your time. The floor is yours, sir.
So yeah, hello everyone. My name is Richard, and I was lucky to write a complete ERP system with ArangoDB. And the agenda for that talk would be, I wanted to share some information about myself, the project itself, so the ERP system, and how I used ArangoDB in that system. And of course, it's called the lesson learned. What mistakes did I make, and how did I fix them? And also one major topic will be AQL debugging in performance, because there was one point that interested me the most, or that takes the most of the time when writing code. And lesson learned, I have some information to share, so some tricks, some tips, and things you shouldn't do or you should do. And in the end, I have a couple of things that I would love to see in the upcoming version of ArangoDB, and I want to share that as well. First of all, my name is Richard, as I said, and I'm a co-founder of Consultana GmbH & Co. KG. That's my company. And I've been a developer for all my life, pretty much, or it feels like that. And I started my own business around 11 years ago, I'd say. And I'm a typical full stack developer and really interested in all that low level stuff, like writing your own frameworks and working with network-based stuff and protocols, and of course, databases like ArangoDB. And the ERP we're talking about is called DLS ERP. And it's the third ERP system that we are working on. And we started the project in 2017, but we've been working with the company DLS for about 6 years now, because the previous ERP system needed a middleware, and this is where we started with ArangoDB. The company itself is a large-scale caterer, so they deliver food to students and pupils. And when we started the project, it was kind of like a, I would say, not really a startup situation, but the project itself was written from scratch. So we didn't know the real demand. So we kind of committed to, let's say, 30,000 clients in the end. So that was the max limit, but we kind of like crossed the line. We're at 50 or 60,000 now. I'm not 100% sure. And we wanted to build a system that doesn't work with performance tricks. We didn't want to have some caching or state machines. We always wanted to work with live data. So we needed a very fast database and a very fast framework as well. We wanted to have a fully reactive system, so something like probably Meteor.js is something you might know. And we had to host it on-premise. The ERP itself is an app, a website, the terminal, and it is the client and the backend system, and so on. Why did we choose ArangoDB? As I said, we wanted to have a fully reactive system that is really fast, so we needed a really fast database solutions. And we had bad experiences with MS SQL and MySQL and stuff. But the major reason was that at 2014, I finished my master thesis. And my professor, Dr. Stefan Ettlich, is really well known in the area of NoSQL databases. And he recommended it to me. And he told me that it's like a really cool query language. It has multi-model capabilities that ArangoDB is famous for. And it has a V8 engine included. And for me, that I found out that in-query debugging, and it's really fast in general, helped that decision as well, to take that decision as well. The ERP system is like, as I said, a complete ERP system. We have dashboard, we have meal, recipe, distribution planning, we have client management, accounting, and all the stuff that you need to kind of get this company working. Our front end is written in Angular and Ionic, and the backend is basically written from scratch. The whole framework is written from scratch. We used Netty. This is a TCP stack framework that we hooked up with a WAMP protocol. WAMP is a WebSocket communication protocol. And at the moment, we're happy to have only a single node of ArangoDB. And this is probably because we use it as how we are using it now. And I will tell you more about that later. 80% of our communication is RPC to broadcast publish. So obviously we don't use REST protocol. We use WebSocket protocols. And we wanted to do that because we learned lessons from other ERP systems we wrote in the past. We wanted to have all the views in sync. So if a mom and her daughter both have the app open and they would order something, their screens would synchronize. And also the food distribution, if you have two terminals and students would come to the terminals and they have to distribute the meals, they would synchronize and count up the distributed meals in time. And this is what it basically looks like. We have a client, let's say it's the ERP client, or it's an app, or it's the website, and that client would communicate with our router, which is basically the WebSocket server, and that would call one of the API endpoints, and that would call a service, and that would call the AQL, and the AQL performs the serialization, usually a very low serialization because it's just some parameters. And the ArangoDB will execute the AQL with parameters, and that will end up in a projected result. And the projected result will go back to the callback, and the callback will send it to the router, and the router will then broadcast our serialization, our result. Why am I saying that? Or why am I explaining that? The reason for that is that this structure made us realize that very large queries can impact our performance. So what we stopped doing is using something like object ORM. What we do is like we write pure AQL code to develop our business intelligence. And we wanted to put all the code into one very large query to reduce serialization, which is basically the serialization between the callback and the ArangoDB.
Richard, sorry to interrupt. Just wanted to make sure the chat is asking if are there slides right now, or is this sort of just sort of free form? I know you wanted to share your screen earlier.
Oh, this is not good. I wanted to share my screen. I thought I shared it.
No worries, no worries. Thank you, Josh, for bringing that up.
Yeah, thank you very much.
No problem. Yeah, technology.
Technology. Right. If you don't use it, it doesn't work. Anyways,
all right.
So can you see my screen now?
Yes, perfectly. Thank you.
Well, the most important things are going to come now anyway. So yeah, well, the first lesson learned, as I said, was to use very large queries. Because for us, it reduces the serialization, it reduces memory allocation, and this results in a higher performance. And as I said, we put most of the business logic into one query and have, this was the image I was showing before, to have just one serialization from AQL to ArangoDB and one serialization from ArangoDB to our callback. So this is basically a typical API interaction. Our largest query is about 491 lines, and it includes a UDF. A UDF is a user-defined function, which is basically the 8 call or a JavaScript call within the query. And this is the accounting query. That's why it takes approximately 1 to 2 seconds per call. And our largest query without a UDF, so it's basically the second largest anyway, takes around 150 milliseconds. And before we transferred it or before we translated the Java code into AQL, it would take around 700 milliseconds because we had a couple of serializations for them back to the database. So how does the ArangoDB help the ERP system? First of all, we have infinite joining through hierarchies. So if you wanted to join, let's say, a hierarchy of 50 or 60 elements, you would have to write a select with 50 joins. And that doesn't make sense if you don't know the depth of your hierarchy. And that's why this helps us a lot. The capability of, or the readability and the debugging capabilities of AQL are helping us very much, because that's why, or that made it possible to actually write large queries, as I described, and have those zero copy calculations and no serialization or less serialization. I think the readability results in a very easy optimization or results that you can optimize the AQL very easily. And I love the fact that you can use projections, which means that you don't have to gather, let's say, row per row, and then write your extra source code to transform your rows or documents into a view model. You can do that right into your in your AQL. Of course, the UDF capabilities, so the V8 is very helpful sometimes, especially when you want to fix some mistakes you made. And well, as I said, it's very fast in general. We have a couple of collections that have more than 10 million items, and we have joins and everything, and there is no issue with that. So, for example, the largest or the second largest query that I was talking about has, I think, 3 or 4 of those collections included, and it runs on 150 milliseconds, so it's not a big deal. I wanted to just give a quick dive into AQL to maybe understand what I'm talking about in a second. So if you want to read more about it, there's a very good explanation on ArangoDB website. I'll share the link later. And if you have a select, as you know from SQL, it's basically a for loop. And if you have a join in SQL, you would do a for loop and a for loop. So you know that from any other regular programming language. And you would just use an extra filter that that has a statement that would kind of combine those elements. So in that 2 loops. And another thing is temporary tables that you might know from SQL as well are just done like a regular variable assignments. So it's very easy to read. So the learning curve is very low on ArangoDB or AQL. And yeah, well, this is the hierarchy I was talking about. We use infinite joining mainly on the code center. So if you have the main tenant is DLS, and you have those regions and subregions and schools, and those schools are connected to classes, and those classes hold all the students. But the hierarchy is not defined. So our client can define the hierarchy as they want to, as they needed to. So if they need another subregion or even split up a school in 2 sub-schools, they can do that for some reason. And the thing is, it's not really infinite. That's why I put the asterisk. You have to kind of decide what's the max. So in this case, in this case, if you look at the AQL part, we have 0 to 100 maximum edges. And I will show you what it would look like when we execute that code. So I prepared some source code here. So that's a traversal of that hierarchy. And when executed now, you will see it will take some seconds. This is because we have top to bottom. So it's this coast sender is the major DLS node, and we're going down to the client. It's a test client, and you will see this is the result. This is our hierarchy. So if you want to have it a little bit faster, you might want to go from bottom to top if that's possible. So what we want to do is now do it the other way around. So this was an outbound in the first query, now it's an inbound. And what you basically do is you loop over the edges and the vertices from the client down to the coast up to the coast sender, and these definitions here are the edge definitions. So the coast senders are connected by the has coast sender collection edges, and the coast sender has a has client group, and the has client group has a has client collection to connect to the client. And if I execute that one, that's only 1.2 milliseconds with a kind of the same result. So this is just a little preview to the upcoming performance optimization, and to see what I mean when I say that we use hierarchies. So what are the pitfalls or the mistakes I made? One major mistake I made in the beginning was when you first start with document stores, you think, yeah, I want to put as much as possible into one document to have an easy structure and to like kind of reduce complexity. But the problem, as soon as you blow up your documents, they might get really, really big, especially when you add logging or something like that. And on one point, you might be not able to execute UDFs anymore, so user-defined functions. The reason for that is that the Arango space and the V8 space are not the same, so they don't share memory. And it happens that after a couple of months that when the documents grew, that I ran out of V8 heap space. So what I did was I kind of split it up into collections, and could work around with this issue. And the next problem I was facing also was that it happens that the serialization performance goes down really badly when you return like really big documents. And this is probably not just a problem with ArangoDB. I think like any other document store would have the same issues, especially the second one, because the serialization has nothing to do with the database. It's just a matter of fact that you need to allocate more memory. The second mistake that I made, that was a really silly mistake, the decision on how to store database dates. I recommend to use UTC dates all the time, but I did the mistake that I used UTC times, not UTC timestamps, but timestamps with a Berlin time zone. That was quite handy because the front end was in Berlin time zone, the back end was in kind of Berlin time zone, but the real problem was in the end that the database uses UTC time zone to calculate all the date functions, and I had to write my own UDF to kind of convert Berlin time zone to UTC time stamps, and that comes with a cost, and I had some issues with performance. The next thing is, if you work in a environment that is non-blocking like ours, you kind of must use the async driver. Well, you can use the sync driver as well if you have very fast AQLs, but if you don't, if you have larger AQLs that are called a couple of times, you will block a thread in your system whenever you call AQL, even though the AQL is capable of not blocking your code. So that's why you should use the async driver all the time. I had to change like critical code to the async driver in the end. When we started, by the way, there wasn't an async driver available, so that's why we also did that later. What I would recommend, but it's not a must, I would always optimize my AQL from right from the beginning, because AQL is easy to read, but it's not like super easy to read, and it's not a programming language. Sometimes you have to think a little bit longer to understand what you did in the past. So I would always optimize like right from the beginning, and I would always use like good variable names. This is very important, because you have immutable variables, so you have a lot more than if you had mutable variables. And what's definitely what's a must is to fix all the warnings, because if you don't fix the warnings, you cannot debug the code. I'll show you in a second. Thinking about SQL, bugging intermediate or debugging intermediate data is kind of impossible, or I don't know how to do that, or I never found out how to do that. But with ArangoDB, you can actually debug like within the code. And I want to show you how that works. So basically, you probably remember the tree traversal, and we wanted to debug the tree traversal now, and doing by adding these line of code. I'll explain that in a second. And what we can do now is we can just execute it. We can prompt all the edges that are traversaled within that before the filter actually executes. So the ArangoDB will kind of like go from node to traverse down until the filter condition is met. And you will see all the nodes that ArangoDB will traverse through. And if I put that line on the second line, so on the next line, so after the filter, you will see that you can only get the final result. I don't know if that's possible in SQL, but I haven't found anything like that. So it's really cool, because if you have really large queries, you can like you can add this line of code anywhere in the query and get like intermediate results. And going back to my slides. Yeah, what you can do is the warn is actually made for you to actually put in warnings into your AQL code, but I'm misusing it kind of. So if you put a false in here, a false condition, it will always prompt what's in the toString value, and you have to allocate it to a variable, because this is only actually made for filters. So the result will be a false. So A will always be false, where we can ignore that. And we even have conditional breakpoints, because if you have your condition and you not out your condition, your false will only be shown if your condition is met. And if you want to have multiple outputs, you can use the string concatenation to show multiple outputs in one line. This is necessary because you can only have 10 warnings per output. Yeah, now performance debugging. How do I performance debug? This is also actually a lesson learned. It took a while to understand how this works, but I'll show you how I would usually performance debug. First of all, we need something that we want to do is, let's say we want to find all clients or client orders for a day in a meal. So let's say on Monday, whatever year or a month, and let's say meal A or something, we wanted to know how many orders do we have for that day. And to do that, the easiest thing would be traverse up to your coast center, and traverse down from your coast center to your client. This is what we did before. And there's also another edge that I included, was the order dish edge. And the order dish edge actually has the delivery date and the meal ID. So if I would execute that, surprise, surprise, it's kind of slow. because as I said in the beginning, traversing from top to bottom is always very slow. So that would probably take a couple of seconds. Used to be faster. It's probably because of the screen sharing, and it took 20 seconds. So this is really slow. We kind of want to have something like milliseconds. So what I usually do is I profile this query, and ArangoDB comes with a cool profiling tool. And as you see, it's now 7 seconds. It's probably because the collections weren't loaded to memory. And as you see, the thing is, when you have a tree traversal, only the from or the two fields of the edge index will be used. But we put an extra index to the order dish, but the ArangoDB query interpreter doesn't know about the order dish or where it meets the index. So what we're going to do now is kind of hint or make it possible that querying that order dish will use that index. So what I'm going to do now is I'll put that order dish into a let's say temporary collection, and query that before querying everything else, and then just go from top to bottom again and join that result from join all the clients with the orders and result, and output that result. When I profile that, you will see it's a lot faster. It's 4 seconds and something. This is because the ArangoDB optimizer found the correct index. But the problem is the order dish is kind of the order dish is iterated, and the tree traversal is done for every order dish. So that's a little bit slow. So what I want to do, or what I want to have, is I want to have an order dish in a separate traversal of the tree, and then joining them together to make it faster. So what I'm going to do now is this. So I put my order dish into a temporary collection, and I'll put the results of my tree traversal into an extra temporary collection. And in the end, I will just iterate over all the clients that I found and return all the orders that match the client. So if I profile that, you'll see that it's only 200 milliseconds now. So we went from 7 seconds to 200 milliseconds. And it looks very good. So it could be enough, but I think we can do more. So what I usually do is I start checking the calls. So can I somehow reduce the calls? So it's kind of impossible because we have only one call, 2 calls. After that, I would always check the item counts, because we're using the item counts is usually the main goal. And what you can see is that the whole the runtime for all the lines are really low. The only bad runtime is the traversal of the orders. So it's basically just the last line. So what we can do now here is a little trick that I love to do. I would love to, or sometimes I map the result. So how does this work and what does it mean? For me, it's kind of like an index temporary table. What I do is I return, instead of returning just the orders, I would return an order that has attribute that is called like the client ID. So if I merge all the results of this for loop or this query or this subquery part, I would get a map or a hash map that has attributes named by the client ID and values that are the orders of the day or of the day and the meal. And having that means that I could use the order and just take the client IDs, and I don't have to like query again. I just kind of pick the attribute in the orders result, and you will immediately get the result without any querying or calculation that needs to be done. When I profile that, you will see we're on 50 milliseconds. But you have to be aware the merging sometimes takes a lot of performance. So you can see here it's like 60 milliseconds only for the merging, which is pretty slow, considering that you only have 1,000 elements. So you got to be aware of that. You cannot always use this trick. And for some reason, yesterday I thought maybe we can do it even better. And what I tried was I just swapped those. Those statements. So I firstly called the tree traversal to get all the client IDs, and then I would only return the ordered dishes that actually meet the client ID or any of the client IDs. And why did I do that? The reason for that was that sometimes you just get a better performance from using the from, but in the end, it was just the merging didn't happen. So when I profile that, you will see you end up with 33 milliseconds. And what's worth knowing is I also opened 2 other versions of ArangoDB. This is our current version, the 3.4. And when you execute these in higher versions, you will get 20 milliseconds. And on the latest version, you will get also 20 milliseconds. Okay, it's pretty close, it's pretty equal. But usually it feels like that using higher versions will always result in a better performance. Sometimes there are versions, intermediate versions that sometimes don't have a better performance. I don't know why, but I think the latest version, the 3.8, has a all over very good performance in general. Yeah. So this is how I basically try to optimize performance, and you get the chance to ask me questions, or maybe when I went too fast, you can ask me questions in Q&A after the talk, the session. So what I usually do is when I try to optimize, I use the profiling, obviously, and I want to reduce the item counts and use temp tables, as you've seen. And I would always try to find the suiting indexes right from the beginning. And it's good to know that from Arango 3.5, that's why I wanted to update, you can actually give index hints. What's good to know also is that you should reuse V8 calls, because V8 calls always have those serialization and transferring from Arango space to V8 space. And the result size obviously matters too. If it's like too large, you would have problems. And what sometimes happens is that you double query data sets in larger queries. So you should watch out if it's for some reason possible to just query results or a sub-query just once. And yeah, this intercepting graph traversals is what I did was from the first query to the second query. So if you have an index somewhere set, or it's possible to use an index, you can kind of stop the tree traversal, use that sub part of the tree traversal and put it into a temporary collection. So what's good to know? First of all, something I found out about a year ago, you can actually not just pass primitives as parameters, you can also pass objects and arrays. So it's worth knowing, I think. And sometimes you may want to use something like a distinct and wanted to assign it to a variable. Especially when you work with documents, distinct is not that easy because it's the structure of a document matters. And if you want to, for example, use an ID as a value, as a comparison value for let's say distinction, I don't know how you say that. You can do that by using the values in zip. So what does it do? It takes a list of elements, and the star, the asterisk actually says only return all the ID elements as an array, and it kind of does the map trick that you've seen in my performance optimization, and it maps an ID to an element, and whenever an element doubles with the same ID, it will replace the element that's already in the spot of the ID. And zipping them together will make the trick. And if you, well, in the end, you only want the values, so you can take the zip result and return it into an array. If you want to open a new scope, you can do that by just returning a value in brackets. This is handy when you use code snippets that you wanted to test separately. That's what I was talking about in the beginning of the talk. You can do that and reuse variables, because if you have a, let's say, global variable in your AQL, you can never use it again. And if you kind of scope it for some reason, you can reuse it a couple of times, or reuse your code snippet a couple of times in your AQL query. The merge with the for statement was the trick that I did in my performance optimization. And one really good thing to know is that the null value comparison is kind of not as expected, or as you would expect it to be. Sometimes you have elements that have null values, and a null value is not equal to 0, because if you return null is lighter than -2, you will get a true. But if you do the same thing in Java, let's say JavaScript, you will get a false. And for me, it's more natural to say null is less than -2 instead of it's greater. And to fix that, I made this not null statement, and you can use it to kind of fix it. I don't know. I opened an issue, it's still open, so maybe it is a bug. I don't know. It's not a bug. It's just different. What's also good to know is I would always have my index information in both vertices and edges. So if you have a traversal tree and you created your tree based on on your logic, and you sometimes don't always want to traverse your whole tree. So you always sometimes you want to just traverse parts of it. And to hook into that tree, you may want to put those indexes not just in the edges, or not just in the vertices. You want to keep them everywhere. So, for example, if I wanted to know what dish is planned for a day, I can use the has planned dish edge, and just use the delivery date and the meal ID to get a result. Or I could use the dish The dish also has the date and the meal ID. And yeah, what I would love to see in ArangoDB in future versions is tabs in the query editor. That would be cool to have like multiple queries run in parallel. And I would also love to see something like a null save greater than and a null save less than. And a better IntelliJ support would be quite handy. And of course, to get rid of the one false to string thing, I would love to see a simple debug variable 1, 2, 3, 4, 5, 6. And I love those array operators, and I would love to have them on maps as well. And I also would love to have a sorting. And finally, when you want to put everything into a very large query and into one query per request, I would also love to have, instead of just an upsert, an upsert that also deletes at the same time. Because doing that, you would also always need a transaction. And this is possible, but it's not as simple as writing just a plain string with AQL code. So that's it. I'm happy to answer your questions. Yeah.
Standing ovation. I'm giving you a standing ovation right now, Richard. Thank you so much. Great presentation. Yeah, so now we're rocking right into the Q&A session.
Yeah.
I'll be reading out the questions for you, and please feel free to ask Richard any questions. So we'll start with the first one. Did you have to struggle with large data sets, 1 million, and run into issues with offset and limit? For example, when paging through grids, it's actually not 1 million, it's like 1 MIO. I'm not sure what MIO means.
Probably 1 million?
Yeah.
No, actually not, because all our very large collections are not listed. They're usually just part of the traversal tree, so not really. But I think if you have issues with that, I think the Arango search talk will help you with that, because I think the Arango search will kind of get over that issue.
Yeah, and we have 2 Arango search talks coming up right after this. Next question, do you use JetBrains data grip to work with AQL?
No, I didn't know. Does this work? I didn't know.
Well,
no, I usually just work in the what you saw now. So with the default ArangoDB tool that comes with ArangoDB.
Okay, cool. Next question, when you are talking about the V8 engine, is that the same as using the Fox services?
No, the Fox is not the. I think Fox uses the V8 engine as well, but I'm talking about user-defined functions. When you define a user-defined function, it's basically just a JavaScript function that is executed within the query. And whenever you pass something into the UDF, you will pass it to V8 scope, and the V8 will kind of have to instantiate memory or allocate memory, and this allocation costs a lot of time. So it's kind of a serialization process, and that's why when you have, let's say, 10,000 items or 1 million items that you're querying on, and you have to always allocate the space, that will give you an insane performance.
Okay. Next question. With reduced V8 calls, do you mean avoid Fox services, or has this nothing to do with Fox? Yeah, I think.
Actually, I don't use Fox at all. I think Fox is this is something that you can use when you use REST or microservices or something. Our system is kind of like a mix between a monolith and a microservice system. So we kind of wrote it all by ourselves. So I don't really need. I never mean Fox. I never used Fox, to be honest.
Perfect. Did you have issues with sort performance after joins?
Yeah, this is Arango search topic as well. So check out the Arango search topics sessions.
Yeah, perfect segue. I read documents should be around no more than 70 kilobytes in size for performance. That seems pretty small. Do you agree? Is that a reasonable size? A simple chat app with embedded messages could easily go over this example.
Yeah, this is what I meant. It's a good example. If I would write a chat, I would never put one chat into one document. I would like split it up. But this is something that I would have done in the beginning too, because yeah, it feels like natural to put everything into one document and just say, just get the chat and just push it to the user. But I would split it up into a collection of chat entries, and then merge them together and give you just a part of the result. And I had documents that were like, I cannot say it in kilobyte, but in lines, I had documents that were like 50,000 lines, and they would still perform, but they would perform very bad. But it didn't crash in the end. Yeah.
It seems like while we wait for more questions, I can throw one at you. When you were first beginning the project, and I imagine, were you shopping around for databases? And I wonder if you were, like, what were sort of like your checklists in terms of like, oh, this one needs to do this one needs to do that, and how did you fall into using Arango?
Well, yeah, the thing was that I was checking out MongoDB in the beginning because I wanted to stop using SQL and just this row-based stuff, because for me it seemed to be very old-fashioned. And the issue with MongoDB was that the kind of this joining and the querying didn't really work out for me how I wanted it to. And looking at ArangoDB, and also the recommendation probably helped a little bit. It kind of felt like there's everything I need. And for me, it was a really big project. And looking at the ArangoDB, for me, seemed like you cannot do anything wrong with it, because it has everything that you need to finish the project, and there's like no limits. You know what I mean? Like, if you look at other databases, you sometimes kind of feel like there are limits. Like if you search for joining documents in MongoDB, for example, you will find answers on Stack Overflow how to do that, but they all seem tricky, and people recommend to not use it. And I don't know, for me, when I started with ArangoDB, it was like you look at it and it looks like the all-in-one solution for every needs that you want. You have this graph, you have AQL, you have like everything that is necessary to do everything that's going to happen and you don't know about, you know. And that's why I used it. And it's really fast. It's like really fast, even though you don't have the proper index, and if you don't know a lot about performance optimization, it still does a good job. And this is probably why I wanted to start with it. And I had some comparison between MySQL and some comparison about MS SQL, and especially the MS SQL project we had before. Like the old ERP system they used was an MS SQL project. And trying to get that fast was really impossible. And so putting Arango as an intermediate data store was like worked out really good for us, and it speeded up the whole project a lot. So that's why we got stuck with ArangoDB.
Awesome. You'll have your $20 in the mail very soon. I'm just kidding. I'm also wondering about you know, when you first began the project, sort of like how did you think through or plan out what features you could do or could not do? Was it sort of like a trial and error sort of thing, or did you sort of like blueprint itself out and just ran with the plan? What was your sort of strategy on that?
No, we actually planned the whole project. Like we planned for 5 or 6 months and had a complete wireframe on everything, and we were then evaluating what has to be done, and yeah, what needs to be, or what should be possible and what should not. And especially the tree traversal or the hierarchy traversal was a big deal for us, because they didn't know how to structure things, and whenever you don't know how to structure things, document stores and tree traversals come like really handy. We don't use it as a real graph tool like you would expect it to, so we don't have geographical stuff and issues. But I think this infinite joining, I know it's not really infinite, but the kind of infinite joining is a really, really strong tool. And whenever you use hierarchies in other systems, and my last ERP system, it was about hierarchies as well. It was a real big pain, and you had to kind of have calls and calls and calls and kind of do all the logic in your whatever Java, C, or PHP code. And that was a bit of a pain. And doing it all in the database with one query that is like that size is like really, really helpful. Yeah.
Awesome. And I'm sure you covered a little bit about this in your presentation earlier, so I wanted to see if we can expand a bit more. I'm curious to know more about like whether it's functions or features in Arango that sort of you would recommend to other people as like, oh, here's my advice, or here's some tips to save you time or work or save some effort, you know, that maybe might not be well known, or that you just sort of like, yeah, I always recommend do this particular way, do things this particular way. What do you think?
It's part of my slides there, the good to know things. I don't know. There are so many things. I think the best tip that I can give is to really start learning the AQL language, and not use your developing language of choice, whatever, Java or C or whatever, and trying to put everything into queries, because they, if you put everything in a query, you don't have to swap between spaces between memory spaces, and don't have to allocate memory that's unnecessary, and have communication time between the database and your whatever software you use. And to do that, you kind of have to learn the language, the AQL language, and I would recommend to not fear the language and just do like little snippets. I would recommend to, if you have your goal or your task, I would recommend to try to put it all into an AQL, even though it takes you a lot longer in the beginning. But you will benefit from a very high performance and yeah, a better result in the end, I think. And especially the projection is a big thing for me. The projection is something that I didn't know in the beginning was possible or would help me. But projecting a result, or just making the result or the transform your result in a way you will use it in your front end helps a lot. So what you could basically do, but I never did that, is produce a JSON string and put that directly to your front end, so there will be no serialization in your actual server code. So you could have kind of like a zero copy thing going on, and that would even more reduce your performance, increase your performance. Sorry. Yeah. So, but this is why I put this topic on so heavily. This about large queries. I would recommend that a lot, even though sometimes the optimizer takes some time too. But in the end, you will always save time, definitely. Like, as I said, I have queries with a couple of collections with a couple of million entries, and I join them a couple of times and transform them, put logic into them, and still have like 100 milliseconds or something. And for this very, very large queries, I think that's pretty amazing.
Next question, and I think it'll be the last one. I think this one we might have covered it a second ago, but we'll just sort of touch on it one more time. Patrick is asking. Oh, okay. Actually, two more questions, if that's okay.
Perfect. Yeah.
One is, did you use Fox? If not, why not?
Okay, that's a good question actually. I think Fox is really cool. I like the intention of it. Basically, I was thinking of using it because it runs directly in the database. So it's kind of this saving serialization time, saving communication time. So it's good to use. But the thing is, as I said, our goal was to have RPC to publish, to keep all the views in sync. So to synchronize all views, let's say you have two apps, and one app is ordering a meal or a dish, and the other app should update that view immediately. So when you have an RPC call on that side, the server will respond to both clients. And this is not possible with Fox because Fox is a pure RPC or REST-driven system. And we didn't want to use REST in general. So the limitation for not using Fox was basically REST.
Okay. All righty, down to the last question. I think this is going to be a good one. What do you tell your clients if you choose ArangoDB and they tell you the company's too young and might be a liability in the future in regards to long-term enterprise level support?
That's a very good question. The thing is, we kind of saved the company with our first ERP solution. So they had a very poor performance with the last ERP system they used, and we hacked into that database and kind of made things possible that the original software wouldn't provide. And we used ArangoDB because they didn't like the performance. And I said, if you want to have better performance, you have to trust us. And that was kind of a little project compared to the project that we're talking about now. And I think the trust in what we do was high enough to let us choose whatever we want. That's why we were actually able and lucky to develop a whole ERP system from scratch. Like usually they would say something like, we want software that is not written just by one company. We want to have, I don't know, some open source ERP system and hook into whatever you want, you know. But we were happy to choose our environment, to choose like nearly everything, and we would get everything that we needed to create the software that runs the best now.
Awesome. Well, Richard, I can't thank you enough for lending us your time and sharing your experience. Your presentation was super helpful. How can people stay in touch? Reach out if they have questions or want to follow up. What's the best way to reach you?
I think the best way is to either send me an email, check out my GitHub account, or maybe, I don't know, probably an email would do it.
Cool. Yeah, I can tell you're not much of not much of a social media guy, so that works. That works. Yeah, perfect. Well, Richard, thanks again for your time. Awesome presentation. Great way to kick off Dev Days Day 3.